Hi everyone, today we are going to look at LeetCode problem number 2136, earliest possible day of full bloom. So in this question we have given n seeds, and for n seeds we have plant time and grow time, and we have to plant all the seeds such that we will return a result which is making the seeds bloom the earliest way possible. So let's see this question with example. So let's look at the first example, which is this one only, and we are having PT and GT. PT is the plant time and GT is the grow time. So the brown one is represented as plant time, the green one is represented at grow time. So let's see first how they are planted. For in this example, like we are given plant time as one here. So the zero have taken plant time as one. Then we are taking two, one, two, and it's blooming on day three. So this should be here. Okay. After that, we are having uh four of the like we are having plant time four of C2. So after it finished from here, then we are planting from here, and we have taken 4 days. Then after that, we are having three as grow time. So three time of grow is here. Then after that, the seed is blooming at eight. After that, on three, we are the last seed is taking three times. So we'll start from here, and it will take three time. And after that, one unit it will take for blooming, and at the ninth position it will bloom. So this is for if we'll follow this one P1, P2, P3. But what if we will follow P2, P3, P1? Then you can see this. If we'll follow P2, then like it will take 4 units of time, and after that 3 units to grow. And similarly for after P2, then it will you go on P3, so it will take three amounts of time. And similarly, like we will get the flower bloom at 10, which we don't want. We want this to be minimum. So let's see how we can approach this problem. So we were looking at the example which was not that much great. So let's look at some more example. So in this example, I have taken plant time as same, but we are having different grow time. So grow time for seed one is 3, then seed two it is 4. So what we'll do, like there will be only two, either plant one, plant two, or either plant two first, then plant one. So if we'll plant two first, plant one first, then it will obviously take two, and then the rest will be for the grow time. And after that, it is finishing on 8. It is finishing on 8. So if we'll look into this P2, like if we'll go for P2 and P1 first, then it's same. Yeah, it's same exactly as that one, but we are having difference in this grow time. So you can see, like, for if we have followed P2 by P2 then P1, like we are getting our time reduced. So what, like the plant time was same exactly, the only difference was the grow time. So that means that our answer is affected by the grow time. Let's see, let's do one thing. Let's keep the grow time as same and use different plant time and see like whether it is affecting or not. So this is another example. So this is another example with the plant with grow time same, but we are having different plant time. So this will be the case. So we'll for two, like this is P2 and P1 first. So for P2, it will take 2 units of plant time, then 2 units of grow time. So it will be finishing here 7. And similarly, like if we'll follow the same, then it will be taking like both of them are finishing on the same time. Then that means like the plant time is not even affected at all. We are just considering this grow time. So if we can observe this one, we were getting our less uh, po- pop time. The bloom time was less when we used this P2 first, which is of 4. So that means like
we need to do like we need to use the grow time first who's having less values. So we have, if you if we would have gone for P2 P1, then we would have got our right result, because like we were taking the highest grow time first. So this is the thing, this is the intuition, like we have to sort the grow time. Now that we have sorted the grow time, so let's see what we can do. So this is the code for the question, and I'm taking a priority queue which will like we'll be adding the plant time and grow time here, and it will be sorting this automatically. So in the top we'll be having the highest plant time, and like in the top we'll be having the highest grow time. So after that we are having bloom day and seed planting day. So this is for like calculating. Suppose like we have let me take one example. Suppose we are looking at in this example, example 2, and we are having this plant time and grow time. So we want to get the minimum, which is 9. So how we can proceed for that? So first of all, like this is the existing data which we have given. So we have now sorted it according to the grow time. So it will look something like this. So what we need to do, we have seen that we need to just sort it. After sort, we need to calculate this one, the bloom day. So how we can calculate the bloom day? The bloom day is actually this one. Like if we are having two seeds, which is x1, like we are having two seeds s1 and s2, which is having plant time as x1 and x2, and grow time as y1 y2, then we, like it will look something like this, like the time for completing the seed one it will take x1 plus x2, but for completing the yth element it will take this amount of time x1, which x1 is the, like it will take this one time, uh, definitely, because like we can only plant, I mean we can plant one, after that we can't plant. If we have started this one, like we have to finish this one first, then we can plant, and after that like we can plant the other seed. So we will be having x1 x1 plus x2 plus y2 for seed y, and for seed x we will be having this, and the maximum of this we would be printing. So why we are doing the maximum, let me show you. So if we'll take at this example 1411, okay. So we have sorted this in by the grow time. So this is the grow time, this is the plant time. So one is taking grow time, and we this is the plant time, and it is blooming in this day, which is fifth day. And for this example, like the second one, we are having plant time as this, and the grow time is this. So the approach we are using is we are having our we are having two things. We are having bloom day equal to 0, and we are having seed planting day as 0. So initially both of them will be 0, okay, and we will be picking the top elements first. So we have picked this top element, so it will be having these two things. So what we'll do like this, bloom day. So this is the bloom day. Bloom day will either be 0 or seed planting day, which is already 0, plus 1 plus 4. 1 plus 4 is this plus 4. So it will give us 5 here. Okay. This will give us 5, and then we have to compute the seed planting day also, because if we want to like use this, like we have to follow this, you have to understand this. Um, so seed day will be 0 plus, like existing was 0, and we are just adding this one here, and it become 1. After that, like we are having the RC2, and we are checking the bloom day, existing bloom day, which is 5, and then after when it will be finished. So it is finishing before this one. So we are just computing this. So it is finishing on the third day. You can see here, and it is computing on this day, and we are just checking the maximum of these two, which is 5. And the answer will be 5 also. And after that, like, we are updating the setting there. So let's look one more example, and we'll understand it better. So this is the example 2 which we are looking. We have sorted them in this order, and we are processing the seed one first. So seed one will be this one first. So we have added 0 plus SD. Okay, so we will be adding these two first, so it will be 3, and our seed day will be 0, which is existing one, and plus 1, which is this one. So it will be 1. So the seed 1 will finish here at uh, at 3. It will be finished. So we'll process the C2. So for C2 we are computing this one, and like the existing seed one is 1. So 1 plus 3 plus 2, which is this one, 3 plus 2, and 3 is like the earlier bloom day which we got. So it is having 6, and we'll update our SD also, which is 4. And seed 3, like, will do the same. We have our existing as 6, and we'll just follow the same thing. And at the end we are getting answer, like, our bloom day as 9, and you can see we are getting output as 9 in this question. And because, like, we are following this one, we are taking all of our elements and adding them, and after that we are checking the bloom day. Is it like we have seen, like, we need to check this condition. These are the two things, and we have to find the maximum of both of them. So it can be either this one or the combination of, like, the next one, because, like, we can have this one first, like the seed one could be finished first. So that's why we are taking the max. And if I will submit this, like, it will be submitted, and it is pretty efficient as well. So see you in the next video. Thank you for watching.